Okay, we are going to look at the second part of absolute value, and you're going to find some of this to be quite a challenge here. We're looking at adding two separate absolute value expressions together, and we're going to use the zeros of each term as kind of guideposts for us. So we know that for 2 minus x, that will be 0 at 2. So I'm going to mark this boundary right here as being 2. And similarly here, the 0 for 2x plus 5 is minus 2.5 or minus 5 over 2. So those are kind of our reference points. And what we're going to look at is, well, what happens when it's less than minus 5 over 2? What happens in the middle? And what happens outside of it? So let's consider first on the left-hand side of minus 5 over 2. What do we know about that? Well, we know for sure that 2x plus 5 will be, if you think of a number, say minus 3, and you plug it into 2x plus 5, it's going to be a negative result. If we think of 2 minus x, it's going to be a positive result. So the resulting expression would be that 2 minus x, when we evaluate the absolute value, will be positive, and the 2x minus 5 will be its opposite or subtracted. So I'm just going to put it like so, because in order to make 2x plus 5 positive, we must put a minus sign in front, because otherwise it will be negative for absolute value purposes. Now in between, what will happen? Well, greater than minus 5 over 2 makes 2x plus 5 positive. So anything above that, it's going to be positive already. We can leave it as is with a plus sign in front. If you want to keep it in brackets, you can. It's probably a good habit to do. Same thing over there. Now, what about 2? Less than 2. Well, if it's less than 2 and you think about, say, 0 or minus 1, that's going to still be a positive result. So we can leave this as is. And then the third interval, if we look at, again, 2x plus 5 first, well, it's going to remain the same, because no matter what value we pick, it's going to be positive. And now the 2 minus x will be negative for anything greater than 2, so we put a minus sign in front of that. And we were supposed to write an expression without absolute value signs, so we're going to have to simplify each one of these. What are they actually equal to? So dealing with the x's first. And then over here, we get 3 separate expressions, which will lead us to an answer that looks like this. That the absolute value of 2 minus x plus the absolute value of 2x plus 5 equals 3 possibilities. And I will start with the positive version. So it will equal 3x plus 3, or it will equal x plus 7, or it will equal negative 3x plus 7. Sorry about that, x. It's not excellent. But we have to consider the interval. So if x belongs to the interval from 2 to infinity, and I'm going to include the 2 in that. And then when I go to the next interval, if x is between minus 5 over 2, and I'm going to make that include minus 5 over 2, but it can't include 2 because 2 is already included in the other interval. And then the third one, if x belongs to the interval from minus infinity to minus 5 over 2. Now, because we're not evaluating an actual value, these brackets here are really arbitrary. The basic rule, though, is that you can't include 2 in both. So you got to pick one or the other, and when I look at your work, I will take that into consideration. Now, there are some properties of absolute values we also need to look at here, and I'll refer back to them in these examples. These you're going to find really easy. What we're going to do is we are going to make one side equal to another. So very similar to what you did in Math C30, if you took Math C30 when you proved trigonometric identities. All right, let's take a look at 2a. If we take a common factor of minus 3 out within the absolute value, and I just picked the left side, we would get this. And if I use the property of multiplication, that we can separate that into 2 different absolute values, we would get this. And clearly, the absolute value of minus 3 is 3, so we end up with that. So you could write QED if you want, that I've proven what I meant to prove. one side is equal to another. And basically that same process would be the same for B. Take out the common factor, absolute value it. Now with C, you've got a square root that you can factor, the square root of x squared plus 1, because when we factor that, that's what you would get. So then what do we know about this? Well, this is a principal square root, which means that it has to be positive. So how do we identify that this answer has to be positive? We put absolute value brackets around it. That the square root of anything squared is itself. How do we make sure it's positive? Put absolute value brackets around it. So that's how that one would work. I'll let you consider D and E on your own, and you'll get some practice in your assignment. Otherwise, that's it. I think you should be good to go, and I will be glad to help you as you work.